Section 3.6 is on multiplying matrices. In order to be able to multiply two matrices, the number of columns of the first matrix must be equal to the number of rows of the second matrix. So let's take a look at an example here. Here I have matrix A that has dimensions m by r, so m rows and r columns, times matrix B, which has r rows and t columns. So the inside numbers here, the number of rows of A, the number of columns of A must be the same as the number of rows of B. And then the product you're going to get is going to be the number of rows of A by the number of columns of B. So my matrix product A times B is going to have m columns and m rows and t columns. So let's take a look at how we actually multiply two matrices. Now it's a little complicated. It's not just a matter of multiplying corresponding elements. It's not just going to be like A times E and B times F and so on. You need to go across the first row of the first matrix and down the first column of the second matrix. So I'm going to do A times E plus B times G. See how I did that? I went across A and down B. So A times E plus B times G gives me my first element in my product matrix. Then I'll go across the first row and down the second column. So A times F plus B times H, and that gives me my second element over here in the top row. Now I'm going to focus on the bottom row of matrix A and go down each of the columns. So C times E plus D times G gives me my element down here, and C times F plus D times H gives me my element in the lower right. But before we multiply any matrices, we need to see if it's actually possible. So we need to determine whether each matrix product is defined. In other words, can we actually multiply these two matrices and get a product? And if we can multiply them, we need to state the dimensions of the product. So the first thing we want to do is look at these two numbers on the inside. Is the number of columns of A equal to the number of rows of B? And yes, indeed it is. So yes, this matrix product is defined. I can multiply these two matrices, and my product is going to be a 2 by 3 matrix. So you take those outside numbers, the number of rows of A and the number of columns of B. Let's take a look at our second example here and compare our two inside numbers here. So the number of columns of A is 4 and the number of rows of B is 5. So no, this is not defined. I cannot multiply these two matrices. So let's take a look at a couple examples of how we actually do this multiplication. So this asks, find each matrix product if it is at all possible. And this is a 2 by 2 and this is a 2 by 2. Square matrices are always multipliable times each other. So my product is going to be a 2 by 2, and I'm going to go across the first row and down the first column. So I'll have 10 times 1 plus negative 2 times 5. And that's going to give me my first element. Now go across the first row and down the second column. So 10 times 4 minus 2 times negative 2. 10 times 4 plus negative 2 times negative 2, or minus 2 times negative 2. Now we're going to go across the second row and down the first column. So negative 7 times 1 plus 3 times 5. And now across the second row and down the second column. Negative 4 times 7 plus 3 times negative 2. And we'll just simplify this to get our product. So this is going to give me 10 minus 10, or a 0. 40 plus 4, which is 44. Negative 7 plus 15, which is 8. And negative 28 minus 6, which is a negative 34. And there's my product matrix. Let's take a look at example number 2 here, and since these aren't two square matrices that I'm multiplying times each other, let's check their dimensions. So my first matrix has 2 rows and 1 column, and my second matrix has 1 row and 3 columns. So since the ones are in the middle and they're both ones, this matrix product is defined, and my resultant matrix is going to be a 2 by 3 matrix. So it's going to have 2 rows and 3 columns. So let's go ahead and do that. And so I'm going to start with my first row of my first matrix, which only has 1 element in it, and multiply it by the first column, which only has 1 element in it. So negative 9 times negative 1, and then negative 9 times negative 10. Oops, make that a negative 10. And then negative 9 times 1. This one's actually coming out to be pretty easy since there aren't a lot of elements in the rows and columns. Now my second row of the first matrix, multiply that by each element of the first column, and there's only one of those. Multiply it by each element of the second column, there's only one of those, and by the element of the third column. So my matrix product is going to be 9, 90, negative 9, negative 6, negative 60, and 6. That one was actually pretty straightforward. Okay, example number 3 here, I have 2 rows and 3 columns. And here I have 2 rows and 2 columns. And because these two numbers here are not the same, I cannot multiply these two matrices, so we say that this matrix product is undefined. And let's take a look at our last example here, just a little more complicated. I have a matrix that has 2 rows and 4 columns, and a matrix here that has 4 rows and 2 columns. And because the number of columns of the first one is equal to the number of the rows of the second one, this matrix product is defined, and my resultant matrix is going to be a 2 by 2. Okay, so let's go ahead and start this one. So I need to go across the first row and down the first column. So 2 times 6 plus 5 times negative 7 plus 3 times 2 minus 1 times negative 1. And that's all going to be one number. I'm going to have to PEMDAS that and come up with one number that's going to be that first element in the product matrix. Now let's go across the first row and down the second column. 2 times negative 3 plus 5 times 1 plus 3 times 0 minus 1 times 0. I always like having zeros. That's nice. And that, simplified, is going to be the second element in my matrix. Now let's go across the second row and down the first column. Negative 3 times 6 plus 1 times negative 7 plus 8 times 2 minus 3 times negative 1. And that's one element. Now across the second row and down the second column. Negative 3 times negative 3 plus 1 times 1 plus 8 times 0 minus 3 times 0. Okay? And because this is a little complicated, I don't know if I can do all that in my head, let's go ahead and write it out. So that's going to be 12 minus 35 plus 6 plus 1 for my first element. Negative 6 plus 5 plus 0 minus 0. Negative 18 minus 7 plus 16 plus 3. And 9 plus 1 plus 0 minus 0. Okay, let's add those up. Negative 12, or 12 minus 35 plus 6 plus 1 gives me a negative 16. That's going to give me a negative 1. Negative 25 plus 16 plus 3 is going to give me a negative 6 and a 10. So all that work for a simple 2 by 2 matrix. But in this section we looked at how to multiply matrices. First of all, how to determine whether or not a matrix product is defined. Can I actually multiply these two matrices? And then the procedure of how to do it.